Welcome back to the discussion of the periodic law. After having enough acquaintance with how to electron configuration, orbital, and the quantum mechanical model, all about quantum mechanical model. So the next move will be applying how to configure and creating a relationship between configuration and the periodic law. So before we associate periodic law and electron configuration, we have to say something about the periodic law. So let's start from the very beginning, which says according to the modern periodic table, elements are arranged systematically so that studying all the elements according to their behavior would be very simple. So let's start from the scratch. So there are trials by many scientists to study systematic organization of elements, and the story begins with uh, Canizaro. Canizaro. And the story goes to next story goes to Mendeleev, and that's the next final story of the periodic table. uh, Moseley, Henry Moseley. So let's see their contribution one by one. Canizaro developed a method that leads to the determination of standard relative atomic mass. Before, in the early days, most chemists use different masses or different representation of relative atomic mass for different elements, so that they end up with different answer. So they were unable to communicate effectively. So lack of effective communication, effective communication, due to lack of standard, due to lack of standard, due to lack of standard. So Canizaro, for the first time, called for a kind of agreement by scientists, which was held in Germany. A meeting was done in Germany, so that they came up with one consensus. With that, they developed a method that led to the determination of standard relative atomic mass. Standard relative atomic mass. So he was the one opening up the chapter to have a very formal way of approaching the property organization of elements. So the next, Mendeleev, he discovered the periodic law. He discovered the periodic law, and organize elements uh, according to atomic mass. So by arranging according to atomic mass, he was able to classify or organize elements with some similar properties. But still, we are going to mention it later when we discuss about Mendeleev's. So he arranged it. So it was successful somewhat, but it has also some limitations. So we are going to discuss what are the limitations and what are the advantages, or what are the biggest contribution of Mendeleev. The next, Moseley, following Mendeleev, he came up with another very refined statement. So elements arranged, elements arranged, arranged uh, according to according to according to the increase in nuclear charge, in nuclear charge, in nuclear charge, in nuclear charge, which means atomic number, atomic number. So we are going to see the different contributions made by Cannizzaro, Mendeleev, and Moseley. Especially, we are going to focus on Mendeleev and Moseley, and we are going to compare and contrast Mendeleev's periodic table and Moseley's periodic table. And there is also an important term introduced here, periodicity. Periodic. Here also we have periodic, which means periodicity. So we are going to see also periodicity in both cases. So we are going to have, in the case of, these are also, the arrangement are periodic. What does it mean, periodic? What are the limitations in Mendeleev's, and that limitation is solved in Moseley? In what way? We are going to see right after this discussion.